You know that feeling when it seems like every hour there's some groundbreaking AI announcement? Keeping up feels less like staying informed and more like uh, trying to drink from a fire hose. It can be a real challenge, right, to make sense of it all.
It certainly can. And that's why you're here. Welcome to the deep dive. Your way to cut through that, constant barrage of information. We take a close look at a range of sources, break down the complex ideas, and pull out the insights that truly matter, all tailored for you.
And for this deep dive, we're focusing on a particularly interesting area: AI trends and policies as seen through a Chinese lens, specifically the sixth issue of China Perspectives. We'll be putting this alongside the perspectives of other leading thinkers to get, a well-rounded understanding of AI's current trajectory and its broader implications. Our goal is to give you clarity in those aha moments without leaving you feeling like you've just wrestled a digital dragon.
Precisely. To get there, we've immersed ourselves in a pretty diverse set of materials. This includes a YouTube transcript of Geoffrey Hinton discussing the evolution of AI, the impressive capabilities of large language models, and even the fascinating possibility of backpropagation in the human brain.
Hmm.
We also explored his 2025 Martin lecture on Boltzmann machines, looking at their history and, their relevance to the neural networks we see today.
Right. And then we have that really insightful excerpt from AI Trends and Policies, China Perspective Says This. This gives us a specific viewpoint on computational architecture, governmental risk considerations framed primarily around financial and economic stability in this particular issue, and the significant idea of a national level war in the
Yeah.
realm of AI competition.
Yeah.
It's important to us that we present this Chinese perspective objectively and neutrally, just as it's presented in the source material.
Building on that, we've also examined the thoughts of Ray Dalio through his writings and interviews on economic cycles, the dynamic between the US and China, and his own sort of similar characterization of AI development as a national level war.
And finally, we've taken a deep dive into an interview with Yuval Noah Harari, where he delves into the fundamental nature of information itself, the unique agency that AI seems to possess, the really complex issues surrounding trust and manipulation in this new AI era, and the, well, absolutely vital need for self-correction mechanisms as we move forward.
So, your mission today as the learner is to have these varied perspectives synthesized for you. We aim to understand the current AI trends and policies, especially those highlighted in the China focus source, within this much broader global context of AI development, the potential challenges, and the possibilities that lie ahead. Okay, let's unpack this, starting with something that really stood out from the China perspectives piece.
Absolutely. They make a compelling argument that our traditional way of building computers, the von Neumann architecture, is increasingly becoming a bottleneck for modern AI, especially these massive large language models. It's almost like trying to power a modern supercomputer with the engine of a vintage car, right?
That's a very apt comparison. The China perspective source itself uses the analogy of the shoe needing to fit the foot, where the shoe represents the computing architecture and the foot is the AI algorithm. Their core point is that while we've made incredible progress in making individual chips faster and more powerful, this raw power isn't being efficiently utilized by the complex software running on these large distributed AI systems.
And they specifically highlight the limitations of just throwing more and more GPUs at the problem. They mention this large-scale, low-latency, high-bandwidth impossibility triangle in distributed systems. What does that mean for you and me in understanding this challenge?
Think of it this way. When you have a huge number of processors working together on a massive AI task, you ideally want them to communicate with each other quickly. That's low latency, and move large amounts of data between them, high bandwidth across the entire system, large scale. The problem is, as you scale up the number of processors, it becomes incredibly difficult, practically speaking, to maintain both low latency and high bandwidth simultaneously.
Wow.
You might achieve low latency across a large system, but the amount of data you can move quickly becomes limited, creating a bottleneck. It's this fundamental constraint that means we can't just keep adding more hardware and expect a, proportional increase in performance.
So it's not just about having powerful individual chips. It's fundamentally about how these chips are interconnected and how data flows through the entire system. The China Perspectives piece also talks about a systematic mismatch between the physical hardware design, things like how chips are manufactured and the speed at which memory can be accessed, and the inherent characteristics of the AI algorithms themselves, like how much computation they require and their specific data flow patterns.
Precisely. Even with continued advancements in chip manufacturing, these performance gains can be significantly hampered by inefficiencies in the overall computing architecture. This is what leads the authors to advocate for a more fundamental rethinking of how we design computing systems for AI.
And this is where it gets really interesting. They talk about moving towards domain-specific software hardware co-design to better fit the shoe to the foot. They even bring up mimetic computing, inspired by octopuses, as an example emerging from China. An octopus, how does that relate to computing?
Yeah, it's a fascinating and somewhat unexpected analogy. Think about how an octopus can dynamically change its shape and texture to blend seamlessly into different environments. Mimetic computing aims to create computing architectures that have a similar kind of adaptability, where the hardware can be reconfigured at a pretty fundamental level to better match the specific computational demands of the AI algorithm being executed.
Yeah.
This could involve, like, rearranging connections between processing units based on the software's needs.
That's a pretty radical idea. And it's not just some fringe concept, is it? The China Perspectives piece points out that Turing Award winners David Patterson and John Haneke have also predicted this trend towards domain-specific architectures.
Exactly. The idea of hardware adapting to the specific task is gaining significant traction across the field. The China Perspective source even mentions Tesla's Dojo supercomputer as a prime example where the algorithm defines hardware. It represents a real paradigm shift away from the traditional one-size-fits-all computing model.
And then they delve into this concept of generative variable structure computing, OYO SDSOW. It sounds like it could be a key piece of this puzzle. What's the core idea behind this?
The fundamental idea is to move away from the relatively fixed, rigid pipelines of traditional computing architectures towards systems that are far more software configurable. Imagine a computing platform where the underlying hardware can be dynamically reorganized and optimized based on the specific computational requirements of the AI model being run at that moment.
Okay.
SDSOW, which stands for Software-Defined System on a Wafer, is presented as a potential way to actually realize this vision of generative variable structure computing in physical hardware. Think of SDSOW as the tools and techniques that allow engineers to build these adaptable hardware systems.
So instead of having a fixed set of components wired together in a specific unchangeable way, you have a more fluid and adaptable architecture that can essentially reshape itself on the fly to best handle the task at hand.
Sure.
And what's particularly intriguing is the suggestion that this could potentially enable the creation of high-performance AI systems using perhaps not the absolute latest, most cutting-edge individual components.
Exactly.
It's about the intelligent organization and dynamic adaptation rather than solely relying on the brute force of the most advanced chips.
Precisely. By tailoring the architecture very closely to the specific needs of the algorithms, you could potentially achieve greater overall efficiency and performance, even if the individual building blocks aren't the absolute state of the art. This could have significant strategic implications, particularly for, entities that might not have immediate access to the most advanced chip manufacturing technologies.
Okay, now let's shift our focus a bit. Another really prominent theme that emerges from both the China Perspectives piece and Ray Dalio's analysis is this idea of AI development being a national-level war. This isn't just about companies competing, it's about nations vying for global influence.
That's absolutely right. Dalio is quite direct in saying that this goes beyond mere business competition. The effective application of AI technology, in his view, carries incredibly high stakes for the future global order. It's not simply a matter of who invents the next big thing, but who can best implement and leverage these technologies across their economy and society.
And the prediction is that we're likely to see different development trajectories in the U.S. and China. The U.S. might maintain a lead in foundational chip invention due to its robust innovation ecosystem, but China could potentially excel in chip manufacturing and, crucially, in the widespread application of AI, perhaps due to its efficient manufacturing capabilities and lower costs. The China Perspectives piece even mentions DeepSeek's low-cost strategy as an example of this competitive dynamic.
That aligns closely with Dalio's analysis as well. China's established strength in manufacturing, combined with its potential to deeply integrate AI into those processes for automation, could provide a significant advantage, similar to what we've observed in the electric vehicle and solar energy markets.
Right.
They have a massive scale of global manufacturing output, and in international competition, factors like price and market share can often be more strategically vital than immediate high profit margins.
The long-term societal impacts that both sources touch upon are also quite profound. There's the potential for significant increases in productivity, but also the inherent risk of widespread economic disruption, and the fundamental question of how the benefits of this new cake of wealth will be distributed across society. It's not just about technological progress in isolation.
Exactly. Both perspectives underscore the need for comprehensive, multifaceted responses that extend beyond just technological advancements. The China Perspectives piece even characterizes AI as potentially the biggest industrial revolution ever due to its impact on human thinking itself. However, this also brings to the forefront core issues of human coexistence with advanced AI, the potential for weaponization, and the very real concerns about large-scale job displacement.
Now, the China Perspectives excerpt also briefly addresses government risk considerations, although the specific example provided focuses on the confiscation risk associated with different forms of wealth storage,
Yeah.
specifically comparing gold and Bitcoin. How does this particular example relate to the broader discussion of AI trends and policies?
Well, while the example itself is about financial assets, it reflects a more fundamental theme of national-level strategic thinking regarding technology and resources in a competitive global landscape. The comparison between gold and Bitcoin as stores of value touches on governmental concerns about control, regulation, and the ability to levy taxes on different forms of wealth. Gold's historical role as a cross-border medium of exchange and its status as a reserve asset held by central banks make it more challenging to fully regulate and tax compared to Bitcoin, where transaction records, while pseudonymous, are more transparent on a public ledger.
So while it might seem a bit tangential to AI policy directly, it highlights how governments are strategically assessing various domains, including financial ones, within the context of global competition and potential vulnerabilities. It's about ensuring national economic security in an era of rapid technological change, and AI, without a doubt, is a significant part of that broader strategic calculation.
Precisely. The underlying principle is about understanding and mitigating potential risks at a national level. And in this particular excerpt from the China perspectives, that's illustrated through this specific example of wealth storage and potential governmental actions related to it.
Okay, let's broaden our perspective again. We've looked at this China-focused view and how it aligns with some of Ray Dalio's macroeconomic insights. How do the perspectives of Geoffrey Hinton and Yuval Noah Harari further illuminate this complex landscape of AI development and its associated risks?
Hinton provides a crucial historical context for understanding today's AI advancements. He reminds us of the long journey from, logic-based AI approaches to the eventual triumph of neural networks and the power of learning through adjusting connection strengths, particularly with backpropagation.
Yeah.
His proposed criterion for genuine AI intelligence, the ability to truly explain why a joke is funny, not just getting the setup right, really underscores the current limitations of even the most sophisticated large language models in terms of true understanding and creativity.
And he also uses this really vivid analogy of words as incredibly flexible, multidimensional Lego blocks that interact to create meaning, which is a powerful way to grasp how these language models function. It's a very different perspective compared to Noam Chomsky's more rule-based view of language.
Yes, and Hinton's exploration of Boltzmann machines, while not a direct precursor to the deep learning architectures we see dominating today, offers valuable insights into biologically plausible learning processes inspired by the principles of statistical physics. Concepts like the wake and sleep phases and the neurons that fire together, wire together principle, even with the practical challenges of slow convergence and non-symmetric connections, they laid important conceptual groundwork.
Right.
And as he notes, restricted Boltzmann machines did find practical applications as a kind of enzyme for initializing deep learning models.
But Hinton also expresses some really serious concerns about the potential dangers of highly advanced AI if we don't approach its development with extreme caution.
He even suggests that a big disaster might be necessary to truly awaken widespread concern, and he voices his worry about the implications of openly releasing the trained parameters or weights of these massive foundation models. That sounds quite alarming. It is a stark warning, and it resonates with Yuval Noah Harari's perspective. Harari emphasizes the unprecedented nature of AI as an agent capable of independently creating and disseminating stories, which sets it apart from any previous information technology we've encountered. This raises fundamental questions about how humanity will coexist with this potentially super intelligent entity.
Harari also cautions about the post-truth era being a natural consequence of a free-flowing information market where falsehoods can spread just as easily, if not more so, than factual information. This seems particularly relevant in the age of sophisticated AI, where the ability to generate convincing but entirely fabricated content is rapidly advancing.
Exactly. And he introduces the concept of super objects, such as global climate change and now AI phenomena, that are so complex and interconnected that individual humans struggle to fully comprehend their mechanisms or their totality. This leads to what he calls the trust paradox, our eagerness to develop and deploy AI, something we don't yet fully understand or inherently trust.
The erosion of trust in information is a central concern for Harari, isn't it? He talks about the potential for AI to create inescapable information cocoons, a stark contrast to the early internet's promise of a unifying network. That's a pretty unsettling vision of the future.
It is, and this is why his emphasis on the development of robust self-correction mechanisms becomes so critical, given humanity's, let's say, less than perfect track record in navigating previous technological revolutions. Having built-in ways to detect and correct errors and unintended consequences in AI development seems absolutely essential as we navigate this transformative period.
So as we wrap up this deep dive, several interconnected themes really stand out. We have this compelling argument from the China Perspectives piece about the need for fundamentally adapted computational architectures to effectively handle the demands of advanced AI. Then we see this consistent framing of AI development as a high-stakes national competition, echoed by multiple sources. And underlying all of this are the significant risks and challenges to trust articulated by thinkers like Hinton and Harari, along with the profound and complex questions surrounding AI's broader societal impact.
And it's important to reiterate that we've aimed to present the insights from the China perspective source objectively, placing them within this wider global discussion about the trajectory and implications of artificial intelligence.
So here's a final thought for you to consider. Given these diverse perspectives on AI development, from the foundational hardware required to power it, to the global race for dominance in its application, and the very real anxieties about its safety and societal consequences, what do you believe is the most critical factor in ensuring a beneficial future with AI? It's a lot to contemplate.
Indeed. We hope this deep dive has provided you with some valuable insights and, food for thought. We look forward to continuing to explore these complex and crucial issues with you in future discussions.